Have you ever stared at the night sky and wondered if we are alone in the universe, particularly on Mars? Our fascination with the possibility of life on the red planet dates back to the 19th century. Back then, scientists speculated about the existence of Martian canals, a network of glistening waterways hinting at advanced civilizations. The vision of a Martian society not so different from our own captured the imagination of many. However, as our understanding of Mars deepened, these theories were eventually debunked. It turned out those canals were nothing more than optical illusions, and the imagined civilizations were flights of fancy, not grounded in scientific fact. But these early speculations weren't in vain. They set the stage for a more rigorous scientific pursuit of life on Mars. What these theories did was ignite a spark, a curiosity that pushed us to keep exploring, to keep asking questions. While these early theories were debunked, they ignited a spark that led to a relentless scientific pursuit for life on our neighboring planet. Mars and Earth, despite their differences, share some intriguing similarities. Let's take a journey through space and time to understand these parallels better. In the realm of water availability, both planets have had their dance with this life-sustaining element. On Earth, water is a universal constant, shaping our landscapes and nurturing our ecosystems. On Mars, though water is not currently present in its liquid form on the surface, evidence suggests that it once flowed freely, carving out valleys and perhaps even creating vast oceans. Temperature is another shared characteristic between these celestial neighbors. Just as Earth's temperatures vary widely from the scorching deserts to the freezing poles, Mars too experiences a range of temperatures. Though generally colder than Earth, it is thought that Mars may have experienced transient warm periods in its early history. These warmer interludes, fleeting as they may have been, could have provided the right conditions for life to flourish. Protection from radiation is a vital aspect of any planet's habitability. Earth is shielded by its magnetic field, protecting us from the sun's harmful radiation. Mars, while it doesn't possess a global magnetic field like Earth, it does have pockets of magnetized crust that could provide some protection against radiation. Models of early Mars paint a picture of a planet that might have been more similar to Earth than we can imagine. It's thought that Mars was colder than Earth, but transient warm conditions could have favored the formation of valley networks, much like the river valleys we see on Earth today. These similarities between Earth and Mars, the presence of water, the range of temperatures, and even some protection from radiation, all point towards the possibility that Mars could have once been a suitable habitat for life. But one question lingers. These similarities and evidence suggest that Mars could have once harbored life, but what led to its current barren state? This will be the focus of our next discussion. Stay tuned. A once potentially habitable planet, Mars today presents a harsh, seemingly lifeless landscape. This barren red planet was not always so inhospitable. In fact, models suggest that early Mars was actually colder than Earth, with transient warm conditions possibly favoring the formation of valley networks. Yet over time, Mars has lost much of its potential for supporting life. The degradation of habitability on Mars is influenced by various factors such as water availability, temperature, nutrients, and protection from radiation. The water that once flowed and pooled on the surface has long since disappeared, leaving behind a dry and dusty terrain. Temperatures that may have once been tolerable have plummeted, and the planet's thin atmosphere offers little protection from harmful solar radiation. Despite significant advancements in our understanding of Mars, the exact causes of its habitability loss remain elusive. These unanswered questions underscore the importance of ongoing and future research as we continue to probe beneath the surface and examine the Martian atmosphere for clues. The mystery of Mars's transformation continues to baffle us, fueling our curiosity and exploration. Despite the harsh surface conditions, recent discoveries have reignited hope for the possibility of life on Mars. In the quest for extraterrestrial life, astrobiologists have been particularly drawn to Mars due to its similarities to Earth. This interest has been fueled by recent findings which suggest that Mars once harbored conditions suitable for life. Among these exciting discoveries are organic compounds, the building blocks of life as we know it. The presence of these compounds on Mars indicates that the planet may have once had the necessary ingredients for life to flourish. Additionally, evidence of past liquid water has been unearthed. Water, as we understand it, is a fundamental requirement for life. The existence of past liquid water on Mars hints at a time when the planet may have been a thriving oasis, rather than the arid desert it is today. But the search for life on Mars, doesn't stop there. Current exploration efforts are now focused beneath the surface of the red planet. Subsurface samples are being meticulously studied as they may hold the key to detecting life, or at least preserving the evidence of it. Moreover, scientists are closely monitoring methane levels on Mars. Methane, a gas often associated with biological activity on Earth, could be a potential biosignature, a sign of life on Mars. Every discovery, every exploration, is a piece of the puzzle, bringing us closer to understanding Mars's past and its potential for life. It's a thrilling journey, filled with anticipation and wonder. These groundbreaking discoveries and ongoing research are bringing us closer than ever to answering the age-old question, is there life on Mars? The search for life on Mars is far from over. Our cosmic quest has been driven by curiosity and a thirst for discovery, tirelessly probing the Martian surface and atmosphere for signs of past or present life. The results have been tantalizing, with recent findings of organic compounds and evidence of past liquid water bolstering the potential for Martian habitability. Current research is honing in on subsurface samples and methane detection, bearing in mind that if life does exist on Mars, it may well be hiding beneath the surface, away from the harsh conditions above. The focus on these areas promises to illuminate our understanding of Mars and its potential for life, even if it's microbial. But let's not forget the importance of future missions. With each rover that lands, with each sample analyzed, we aren't just exploring Mars, we are digging deeper into the mysteries of life itself. As we continue to explore and understand Mars, we inch closer to answering the compelling question, are we alone in the universe?